Okay, so we're going to do these graphing quadratics introduction notes. So we have some fill in the blank stuff here. So a quadratic function is a non-linear function, which means it is not a line. It is in the form of y is ax squared plus bx plus c. The squared variable is what identifies it as a quadratic. So if there is not a squared anywhere in your function, it is not a quadratic function. There is a parent function, just like we have with linear functions. It's our basic one. This is y equals x squared. We will create functions that will change this and make it look different as we go. So when graphed, this is going to form what we call a parabola. And it is shaped like a U. It can be right side up or upside down. The left and the right sides of the parabola are mirror images, which means they're going to look exactly the same. If a, which is the coefficient of x squared, is positive, then the graph opens up and it will look like this. If a is negative, then the graph opens down and it looks like this. So that's your leading coefficient. If the absolute value of a, which means no matter the sign, just the absolute value, if it is, the parabola is going to be more narrow if it is greater than 1, which means it's skinnier. It will rise and drop faster. And we'll look at that on some graphs. This is what we would call a vertical stretch. So we had these stretches when we did linear functions, but we're going to have them as well as we do quadratics. If that value of a, the absolute value, is between 0 and 1, then your parabola is going to be wider than the parent function. It rises and drops slower, and this is a vertical compression. So those terms should be familiar to you. So if a is greater than 1, it's a stretch. If it's between 0 and 1, it's a compression. And both of those are absolute values. Okay, so next page. A parabola has an axis of symmetry. A lot of times we just abbreviate this as A of S. This is an imaginary line, a vertical line at x equals a number. You don't actually see it, but it goes straight through the middle, straight through the vertex. Okay, it's going to be what splits it in half. That vertex is your highest or your lowest point. If the graph opens up, the vertex is what we would call the minimum. It's the lowest value. So if it looks like this, here's my vertex down at the bottom. It's my lowest. If the graph was to open down, the vertex is going to be my maximum. So my quadratic would look like this. The vertex is the highest point on that parabola. So then we talk about the y-intercept, and that's your c value. So whatever c is, that point is going to be 0c. So that's just your constant that's being added or subtracted. If c is greater than 0, then the graph is going to shift up. That parent function will go up. If it is less than 0, it will go down. Okay, then we have x-intercepts, and we've talked about these when we factored. The x-intercepts are the solutions. We also call these roots or zeros. When we factored, this is what we found when we were solving for x. Our roots, our zeros, our solutions. X-intercept. A quadratic can have 1, 2, or no solutions. And then the last thing there, a graph of a quadratic is constantly getting wider. It will never curve back on itself. It is never a straight line. It is constantly getting wider and wider and wider. Okay, we're going to go and do one more page. So we have an example here of a quadratic that's already been graphed for you. We just have a few questions to answer with it. If you want, you could pause it and see if you could answer these on your own. It would be a really good kind of test of your understanding. So the first one, does it open up or down? It is down. So since it opens down, does it have a maximum or a minimum? My vertex up here is my maximum. It is the highest point of that quadratic. That maximum is my vertex, and that vertex is at -2, 4. So we're talking about the axis of symmetry. That's the line that runs through the vertex. It's a vertical line. It's imaginary, which is why you don't see it. We can draw it in with a dotted line if we would like. So that's what splits it in half. You can tell that they are the same. So it's an x equals line, and what does x equal? X is -2. All right, the y-intercept is right here. So it's 3, or you could write 0, 3, depending on how you prefer. So then it says, what is the point that is the mirror image? So if I look at this point, my y-intercept is 2 spots away from the axis of symmetry. So on the other side, 2 spots away, is going to be its mirror image. That is -4, +3. Next question is domain. So this is my x values. This is getting wider and wider and wider. I can't see it, but it is. So that means every x value is going to be part of this function. So my domain is all real. My range are my y values. So we're looking at what y values are in this function. So here's my biggest y value. But this keeps going further and further down. So it's all y values that are less than or equal to 4. And then the last question there is, what are the solutions, the roots, the zeros, the x-intercepts, whatever you want to call them. If I look at my graph, it's hitting right here and right here. So that would be a -6 and +2. Okay, there's one more page of notes here that you are actually going to do without me. You have a word bank here to use, and you're going to fill all of these in. We will go over it in class the next time I see you.